Hello again, pre-cal. It's Miss Kosh. I'm going to continue working through these notes. So I'm not sure that I'm going to do all of them. I think I already have a video for this one for sure, and I need to go back and check and see. So we'll see how far I make it. I'm out of time, so there's just too much to do. So hopefully I can give you enough of a hint and let you figure out the missing pieces. Here we go. So this one, we've got this graph. This is just a linear function. It goes down to -4 somewhere, and then it goes up to and over 1, up to over 1. When I plug in, I want an x value of 0. It's 2. Okay, so this is going to be the point 0, -4, and this is going to be the point 2, 0, right? Yes, okay. And so this is that line right here. And so when I go to find the inverse, keep in mind we can switch the x and the y, and so the inverse becomes 0, 2, roughly that far away-ish, something like this, and then the point -4, -4, 0, and that line. So what happens is that they have been reflected. The one should have been reflected over the line y equals, pretend I can draw. Basically what should have happened is that the green reflected over the blue line and gave me the red. Okay, so if we want to find the equation of that, one way that we can do domain and range of the original function. The domain, all reals. The range, all reals. It's a line. And it's not horizontal or vertical, so its domain and range are both all real. Describe any restrictions? None. Find the inverse function. Okay, so I can come along here and say x is equal to 2y minus 4, solve for y. X plus 4 is equal to 2y. That gives me y is equal to 1/2 x plus 2 would be a way that we would typically write our linear functions. So since this is the inverse and it's a function, we can say the inverse of f is equal to 1/2 x plus 2. State the domain and range of the original, of the inverse. The domain and the range are still both -infinity to +infinity. It's a line. There we go. I'm moving fast through this, so hopefully ask me if you have questions. Then I graphed both of them. There we go. So we have, and we can verify, yes, if this is the point -4, 0, we went over 4 and up 2, because this is the point 0, 2. This is point -4, 0. And yes, that's a slope rise. We went up 2 over 4. That's a slope of 1/2. And then we have a y-intercept of 2. So this and this make sense in relation to each other. Okay. So the thing that is the most important, the big takeaway from this easy problem, if I put this on the test or quiz, you should say thank you, because this is a pretty straightforward, pretty easy inverse question. But the point was that I want to show you how this algebraic proof works. So what we can do here is we can show that f of the inverse of f of x would be equal to f is this 2 times something minus 4. Well, that something happens to be 1/2 x plus 2. When I distribute, I get x plus 4 minus 4, which is equal to x, and I have done half of my proof. The other half is that I need to do the inverse of f of x. The inverse is 1/2 of x plus 2, and what we're plugging in for x is the original equation, which is 2x minus 4. So half of 2x is just x, half of 4 is 2, that was a negative, plus 2, and this is equal to x. And that, ladies and gentlemen, is our algebraic proof. Okay, so life is good there. I'm going to glance very quickly to see. Dang it, it's not easy for me to do. Okay, sorry. Hang on just a second. I don't know that I need to talk about this one. Oh, yeah, let me talk about that one. Okay, on this one, this is a parabola. It's got a vertex of -2, -5. So -2, -5, somewhere about here. And this original function is doing something like this, and I'm not overly concerned about its values currently. Okay, so this point, though, -2, -5. So A said, what's the domain and the range of the original function? The domain is -infinity to +infinity. Its range is, it goes from -5 and then up. So it includes -5 and then it goes to positive infinity. Then they said, part B, describe any restrictions. Okay, so on this one, if we were to take its inverse as it is, we would have the points -5, -2, -5, -2. So somewhere here, I need to change colors. We would have this point somewhere here, and then we would have both sides. Pretend I can draw, that's kind of terrible. Anyway, and it would look something like this, and that would not be a function. So it doesn't do us much good if it's not a function. So what we're going to do is we're going to restrict the domain. And so what we want to restrict it to is we want to restrict it to the part that goes off to positive infinity. So we want from the vertex to positive infinity in general. So our restricted, describing our restrictions, our new domain should go from -2 to positive infinity. Okay, so now I can go about and I can switch x and y, and I can say x is equal to y plus 2 squared minus 5, add 5, x plus 5 is equal to y plus 2 squared, take the square root, and then we're going to take this, okay, I'll show you all my steps. And then I end up getting y is equal to the square root. Now technically I should have done the cheer, square root, plus minus, but I don't want the plus or minus. I just want this part that goes something like that. Okay, so that's why I'm choosing this would be the graph y is equal to the square root of x plus 5 minus 2. That's all I want. If I did the plus or minus, then I would end up getting this part down here, and I don't want it. Okay, because then it fails the vertical line test. It's not a function. This is x plus 5 minus 2. And so what was C? Find the inverse function. The inverse function is equal to, now notice I used function notation, so what I have to write has to be a function. X plus 5, the square root of x plus 5 minus 2. D then says, state the domain and the range. Okay, so the domain is my x values would be from -5 to positive infinity. My range goes from -2 to positive infinity. Notice, here's the cool part. This, not that domain. This domain that once we restricted it matches the range here. And the range matches the domain here. Okay, if that doesn't happen, not necessarily this part up here, that's okay if once we restrict it, but if the range and the range of one doesn't match the domain of the other, you did something wrong. Real fast, I'm going to do one of the algebraic proofs just for a time saver. So we're going to say f of the inverse of f. Yes, I've been using the wrong notation. F to the -1, that's the derivative. Oh my goodness, this is terrible. This is to the -1, to the -1. Oh my goodness, Did I do that before? Wow, that's embarrassing. Okay, the other thing means something, but not what we want it to mean. Okay, I don't have time to go back and fix this video, but I'm fixing it now. Go back and change all that notation. It's f to the -1 of, not that little dash mark. Oh, wow. Okay, I'm embarrassed. Here we go. So f was something plus 2 squared minus 5. And that something that we're going to put in, pink. That something that we're going to put in is that new inverse function, which we just said was the square root of x plus 5 minus 2. Okay, so now that plus 2 and the minus 2 cancel each other out, and I get the square root of x plus 5 squared minus 5. Square and square root cancel out, I get x plus 5 minus 5. That just gives me x. Okay, technically, I need to do the inverse of f of x and to finish my proof, but I'm running out of time. So this one, I know I have a video for number 3. I think I have a video for number 4. I'll see if I can, yeah, if I don't, I'll go look for it. Good luck. Practice, 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 and I hope to post the key for you soon.